Hi guys, I'm back, and the problem has been solved. We call it, it's a waypoint of type, the waypoint is of type game object, and then down here, variable waypoint, okay, that's gonna be interesting. Hang on. What have I done here? Okay, so we're shooting a new ball. I've called it variable ball bouncy ball. Ball of type bouncy ball, and I've got bouncy ball like that. So I'll just call this, well, first of all, this is going to be a type game object. It's going to initiate the waypoint thing, but we'll call it a way. We'll just call it way. Why not? And so that should initiate properly. That should not have any problems. Yeah, good. So if I go to capsule, I should have a new waypoint game object, and I'll just drag in the prefab. Bam! And now we'll see if it works. Where am I? There we are. So if I press that, bam! And now we're initiating prefabs. Oh, that's, as Sips would say, oh, that's fantastic. But we're not done. So we're going to see what would happen if I change this quaternion identity to become hit2 dot. Well, what else do we have for hit? We have the normal of the surface array hit, but that would be a vector 3, wouldn't it? Yes, it is. Would a vector 3 wouldn't work as a quaternion, would it? Because objects need to have their need to be initiated with a quaternion. Now I'm wondering if there's a vector 3 to quaternion. Yeah, returns the Euler angles representation. So Euler angles is a vector 3. Is there a vector 3 dot to quaternion function? We'll see. Okay, no, wait, no, there's a second option. Hang on. Besides the functions. Okay, fine. There's also a matrix 4x4. That's interesting. But it's not really what I was after. Alright, so we'll just see. What if I put hit2 dot normal? Okay, first of all, we're probably going to come up with some type of error saying that the code's not compatible. Yeah, no appropriate version. Yeah, but what if there's a 2 quaternion or something? Though it doesn't seem to be that version. Perhaps quaternions can be instantiated. Constructors, yes. No, that doesn't work. Hang on, what's this set from? No, creates. Oh, okay. Converts to a rotation to angle axis. I don't even know how to. I think quaternions are quite different to what I think they are. I think they're more of a group theory thing, even though they can be represented as sets of, with 3 different imaginary numbers and as well as the real numbers. And yeah, I think they would be not representing actual absolute rotations, but I think they represent like relative rotations. But I think in this case they're representing the original rotation is relative to like an initial rotation. Hang on just a second. Yeah, so I think that, like, say if you have something and you times it by the identity quaternion, nothing will happen because the identity quaternion will keep it as it is. But I think what happens is when you initiate a prefab as identity quaternion, what it's really doing is initiating an initial rotation and then timesing that by the identity quaternion to get the new rotation. And I think that's how it would work. They don't suffer from king. Yep. I will learn more about quaternions in my own. Oh, Euler. Wait. Class functions. Hang on. Quaternion.Euler returns a rotation that rotates. Oh, that's perfect. Oh, Euler vector 3. That's exactly what I was looking for. So basically, I just need to write quaternion.Euler. No, I don't want quaternion.Euler because it would just rotate around the normal. And that's not what I want. I want it to rotate so that it looks towards the normal. So, rotate towards, look rotation. Okay, I'll be right back. So, I think instead of dealing with all this, these quaternions, what I'm gonna do is work with Euler angles afterwards. Transform.Euler angles. There we go. Oh, that's interesting. I'll be fine. Actually, hang on. Alright, so I think I figured it out. First of all, I need to, after I do this, I'm just going to use, hang on. I'm just going to use quaternion.identity, but then after I spawn it in, I'm going to use the transform.lookat, and then I'm going to use, in addition, I'm going to use the transform direction. So basically, I'm going to write way.transform.lookat. There we go. It's going to look at our world position. Yep, there we go. Bam. It's going to look at transform.lookat vector 3. No, not vector 3. What is it? It's transform direction hits to dot normal. Bam, 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 bam. So basically, it's going to get the normal. Oh wait, hang on. No, I don't think I want to do a transform direction of. No, that's not what I'm looking for, is it? Because transform direct. No. Okay. Let me get rid of that. It's not transform direction I want. Oh, I know what I want. Transform dot position. Look towards its current position. Yeah. Transform dot position plus hit to dot normal. That should work. So it'll just get its current position, then add the normal of the wall onto it, and then look towards that, and that should work fine. Perfect. Now, the thing is about its current position. Its current position is hit to dot point, but I may want to change that to work with the normal somehow. But first, we need to test this. Oh, here we go. There we go. Now look at it. Look at how the way we look towards things changes how they work and how they can go on top of each other like that, because that makes perfect sense. Oh yeah, look at that realistic graphics. What am I doing? But this is great. This is good experimenting. I could make some type of world generation, like world editing thing with this. And seriously, can I even? I can't even. Oh, I can walk on this. Kind of. Oh, I'm bouncing around. If I try and look at these things, I get stuck. And then it lets me, continue, oh man. Oh no. How am I even... Whoa, I'm falling now.